Hello, welcome to this video on reacting masses. This is suitable for GCSE, AQA C4 module. Could also be very useful for A-level students who've forgotten how to do this and need a recap. So, the whole of this video is going to focus on this question here. When 1.6 grams of methane is burned, what mass of CO2 is produced? It could be any question type where they give you a mass and ask for another mass of some substance being produced. We're going to need two key skills in order to complete this question that I spoke about in my last video, MR and moles, and how to calculate those. So MR, just to recap, is the sum of the mass numbers on the periodic table. So if we look at H2O, on the periodic table we see H as 1 and 1, and we see O as 16 and 8. So just take a few seconds, maybe pause the video to work out what you think it is. Okay, well, the mass number for oxygen is 16, the mass number of hydrogen is 1. We've got 1 oxygen, 16 plus 1 plus 1, that gives us a total of 18. So that's how we calculate MR. It's the sum of the mass numbers. The mass number is the massive number. The other skill we looked at doing was calculating moles. Now, a mole is 6.02 times 10 to the 23 atoms, and we can link it with mass in the following relationship. Mass MR mole, massive Mr. Mole, and from this triangle we can get three equations. Mass equals MR times mole, MR equals mass divided by mole, and moles equals mass divided by MR. These are going to be our two key skills in order to answer questions of this type. So let's get to it. Wardrobe balls moving everywhere. So, 1.6 grams of methane is burned. What mass of CO2 produced? As I said, this is the question type that we're looking at answering. So, first thing we need to do, and this is usually given to you in questions, but you need to check that it's balanced, is generate a balanced symbol equation from which we can do the work for this. So, methane is CH4 plus oxygen goes to H2O and CO2. So far so good, standard combustion reaction. We now need to balance this in order to make sure that the equation is correct. So we've got one carbon here, so we're happy on carbons. Hydrogen, we've got 4 hydrogens here, only 2 here, so we need to put a 2 there. Then we've got 2 oxygens here, 2 times 1, so 2 in the water and 2 here. So 4 oxygens in total are on this side of the equation, only 2 on this side. So we need to put a 2 here. That's now a balanced symbol equation. But what are these numbers really telling us? Well, they're saying that 1 mole of methane will burn with 2 moles of oxygen and make 2 moles of water and 1 mole of CO2. That's what these numbers are showing us. They're a direct link between the number of methane atoms and the number of oxygen atoms. Obviously 1 mole is just a huge amount of atoms, 6.02 times 10 to the power of 23. So, the first thing we need to do is calculate the moles of the thing we can calculate moles of. In this case, that's methane. So step 1 is to calculate moles of methane. We know we can calculate the moles of that because it's given us the mass in the question. We'll be armed with our periodic table, so we'll be able to calculate the moles. So moles of CH4 is going to be equal to, if we quickly think about our triangle, mass mR mole, then moles equals mass divided by mR. Well, my mass is 1.6 and my mR, 12 for carbon plus 4 for each of the one for each of the hydrogens, so it's 1.6 over 16, which conveniently is 0.1. Almost like I worked out the numbers first. 0.1 moles of methane made. Now, if I react 0.1 moles of methane in excess oxygen, it will react with 0.2 moles of oxygen. Because if 1 mole reacts with 2 moles, then 0.1 will react with 0.2. And that will make 0.2 of water and 0.1 of CO2. So, we can now say moles H2O, we're after CO2. Excuse me, we can talk about the moles of water, but let's talk about the moles of CO2. They are 0.1. So we need to compare across the equation. Obviously, if it was oxygen, I'd times by 2, because it's twice as many moles. But as it is, the moles of methane are equal to the moles of CO2. So that's 0.1. And then the third step, now we've got the moles of CO2, we can get the mass of CO2. So step 3 is to find my mass of CO2, which will be moles times mR this time, because cover up mass, mR times mole, and that will give me moles are 0.1, we work those out in step 2, and my mR of CO2, carbon is 12, oxygen is 16, so we've got 2 oxygens, that's 32 plus 12, 44, so it's 0.1 times 44, which means we get 4.4 grams of CO2 produced when we burn 1.6 grams of methane. So that's how we do a reacting masses question. Let's have a look at another example. And then you can have a go. So, if I give you the balanced equation for the production of ammonia, this is known as the Haber process. So, balance this up. I've got 2 nitrogens. So 2 nitrogens here. 3 hydrogens there, times 2, 6 hydrogens. I've got 2 hydrogens here, so I need a 3 there. There, my equation's all nice and balanced. I've put an equilibrium arrow here because that shows what's actually going on, but we're going to assume it all goes to make ammonia. So, let's have a look. If we say if 3 grams of H2 is used, what mass of NH3 is produced? So you might want to pause the video here and just have a go at it yourself. Brilliant. Okay, so hopefully you've had a go at that. Let's now go through the answer. So, if 3 grams of H2 is used, what mass of NH3 is produced? First step is we need the moles of H2. Moles of H2. We don't take into account this big number when calculating MR, it's just here. So we've got 3 grams of H2, that's the mass, divided by the MR, which is 2. So we've got 3 over 2, which equals 1.5 moles of H2. Now, step 2, our moles of NH3. If we've got if we have 3 of these, then we have 2 of these. If we have 1.5 of these, then we have 1 of these. So if we have 1.5 moles of H2, because it's a 3:2, we have 1 mole of ammonia. Now the final step is to get the mass of ammonia, which equals, as always, moles times MR, which equals 1 mole times by the MR of ammonia. Nitrogen is 14, and we've got 3 hydrogens there, so that's 3. So it's a total of 17, which means we make 17 grams of ammonia from 3 grams of hydrogen, obviously assuming that's in excess nitrogen. Hope you found this video helpful. We'll see you in the next one. Like, comment and subscribe. I'm being asked more often, and we'll see you in the next video.